Welcome back, y'all, to another video. Today we're going to look at piecewise functions and other types of functions that we're going to graph. I'm going to try to go pretty quickly, so let's get started. We're going to look at graphs of functions, and first thing we want to do is determine the domain. We need to know the basic shape of the functions, and we're going to plot points and make the functions happen. So now we're going to do linear, quadratic, radical, absolute value, cubic, and then finally piecewise. So let me just remind you of what these guys are. A linear function is a line. It is a line. And then quadratic is what we call a parabola. And then we have the radical and the absolute value, and the cubic and the piecewise. So we've done the line and the quadratic in our previous unit. So let's look at the parent functions. Let's look at these a little bit more in detail. Okay, so there's a couple of different types of lines. This one's linear. It's also a constant. These are called the library functions of graphs, and we have f of x is equal to a number. This is a constant function. It's a horizontal line. But then we also have ones that could be like f of x is equal to mx plus b. That's a line. All right, and so they could be just, slanted lines. Okay, then on the second one here, we have an x to the second. That's the parabola, and we have this u shape. Every equation that has an x squared as its largest power is going to be the shape of a parabola. This third one is a radical function. This is a square root function, and they all look like this. They all have this arm thing. The fourth one over here, this is the absolute value. An absolute value looks like a V. You see that? They're going to look like a V. So the radical, again, looks kind of like this arm thing, and the absolute value is a V. The parabola is this U-shaped, and then, of course, we have the linears. I did throw in a cubic. This one over here is a cubic, and it has this squiggle shape to it. Now, those are the only ones that we're going to do in this video and in this particular unit. We will move forward in our units and do other videos. Now, I want to show you something about each one of these that we might want to pay attention to. The domain. Now, most of these have the default domain of negative infinity to positive infinity, because we know that when it comes to finding the domain, when we look at an equation, we know that if it has a radical, we have a domain issue. And so the rest of them just have regular, normal, default domain of negative infinity to positive infinity. But the radical one, notice it doesn't have arrows on both ends. It only has an arrow on one end. And the domain of that one is different. And we'll talk more about that one when we get to it. So those are the basic shapes that I need you to memorize. You need to know the basic shapes. You need to be able to look at this symbol and say, that's an absolute value. My graph is going to look like a V. And you need to be able to look at this and say, that's an x to the second. That's a quadratic. That's a parabola. My graph is supposed to look like a U. These are the kind of things that I need you to learn. All right, so let's jump in and do one. Okay, so now it says graph each function and give the domain and range. All right, so now we're going to look at this first one. We have f of x equal to negative 3x to the second. This is a parabola. Again, we look back at our sheet and we see that we've got the x squared. Okay, so this is a parabola, and so my domain is going to be negative infinity to positive infinity. So that means any number works. Any number works. Okay, and so we're going to graph it by plotting points. My domain, any number works. Any numbers work because that's my domain. And so I just picked negative 2, negative 1, 0, 1, and 2. All right, so I'm going to take these numbers and I'm going to plug them in and calculate. Let's see what we get. So that's going to give me exponents first. So it's going to be 4. That's a 4. times negative 3, which is negative 12. This is a 1 times negative 3. We have 0 times negative 3, 1 times negative 3, and 4 times negative 3. Okay, so there are my points. And now I'm going to graph this on my grid here. Now, I don't have enough room to do the 12 points, but I will do the ones in the middle. And notice I put a little note here. When you do in MyLab and you're doing these on MyLab, you have to have 3 points on MyLab. Okay, so make sure you know you don't have to have all 5 of them. It is going to require you to do 3 points. And so you're going to click a little tool on the MyLab that looks kind of like that. Looks like that, and you click on that, and then you can graph it. All right, so I have negative 1, negative 3. I have 0, 0. I have 1, negative 3. And then I know it's supposed to be a U, and so I'm going to carefully try to draw a U. There we go. That's that one. Number 2, a domain. I look at it, and I don't see a 2. I think this one's a cubic. It is a cubic. This one's cubic. Notice it from my little 3 right here. And my domain is negative infinity to positive infinity, which means I can do any number. So I just picked those. I pre-picked them because it saved me some time. And I'm going to plug these numbers in. Use your calculator. Stop the video. Calculate these numbers and figure out what these are. Okay, so let's do these. I'm going to have negative 2 to the third, which is negative 8, and negative 8 minus 5 is negative 13. Negative 1 to the 3 is negative 1. Negative 1 minus 5 is negative 6. 0 to the third is 0. 0 minus 5 is minus 5. 1 to the third is 1. 1 minus 5 is negative 4. And 8 minus 5 is 3. Okay, so there are my points. Now, when I do MyLab, this is a cubic. All right, it's going to be a 4-point cubic. So on the MyLab box, you're going to have a little thing that looks like this, and it's going to have 4 points. All right, so when you're doing MyLab, you're going to click on that in order to graph it, and you just do 4 points. Now, it appears that I'm not going to be able to get all these points on here. And no, I'm not going to be able to get that 13. So I'm going to do negative 1, negative 6. I don't think I'm going to be able to do it. I think we're going to have to scale it. Let's see. All right, so negative 1, negative 6. I'm going to scale. It's there. 0, negative 5. I'm scaling by 2s. Okay. 1, negative 4. And then 2, positive 3. Okay, now, I have no idea what this looks like. Oh, yes, you do. If you go back and look at your parent graph, it looks like that right there. It looks like that. That's what it looks like. Okay, so let me try it. Let's see if I can make it do that. I kind of see I got a point here, and then I got kind of 3 points like that. It's exactly what I have, so that's how I'm going to make this thing turn out. I'm going to do my pointer to work. Oh, goodness. Let's try one more time. There we go. And so I'm going to have this like that. Okay. And again, on the MyLab, you just need to type in 4 points. You just dot, 2, 3, 4, and it'll automatically make the shape for you. Okay? All right, let's see what else we got. Okay, so now I've got a radical function and a absolute value function. So this one's a radical, and this one's an absolute value. All right, and now the domain of the radical, this is the one I'm going to have a domain issue. For the absolute value, it's negative infinity and positive infinity. Let's look back at our little cheat sheet here. And we see, I'm going to erase all that. The absolute value, the domain, and it's going to be of negative infinity, and the radical. Those are the ones we're going to do next. And that's what they're going to look like. Okay? All right. So I'm going to do that on the next video. So go ahead, copy it down. Oops, wrong one. go ahead, copy it down and see what you can do with it, and let's come back in just a few minutes. It's just math, y'all. You can do it.